Okay, hello. I'm going to talk about Investigation 7, which is about balanced equations. So I'm going to start off by doing this without any numbers at all, and let's just think about a scale. And imagine this scale has a circle and a square on the left and a star on the right. And the square is perfectly even right now. So we should know what that means. That means that they are the same in weight. And it also means, in mathematical terms, circle plus square equals star, right? The weight of the circle plus the square is equivalent to the weight of the star. Now imagine you want to know what the circle weighs. You want to know what that circle is equal to. Well, right off the bat, you'd probably get rid of that square, right? So say I just get rid of that square. Think about what would happen to the scale if I took that square off. Would it still be equal? No, it would turn into this. If I took the square off, my circle would go up because now it's lighter. It doesn't have that square with it anymore. And my star would go down. So I know that circle is not equal to star alone, right? Circle plus square is equal to star. But I took away the square. Now I don't have the square on my circle side anymore. Now to get this scale to be equal again, there's something I have to do. I could put the square back up here, and then it would balance out, it would be equal again, but my circle wouldn't be alone. That doesn't help me at all. To get this scale even, I'm going to also take away a square amount of weight from the star, right? If I took away one amount on the left, to make it equal, I'm gonna have to take away the same amount on the right. So let's look at this equation. I had circle plus square equals star, and I got rid of the square on this side, and now I'm gonna get rid of the square on this side. So I know that the final weight of my circle is whatever the weight is of the star minus the weight of the square. Okay, that might have been a little bit abstract for you, but now let's try it with some actual numbers. So on one side of my scale, I have x plus 12, and on the other side of my scale, I have 33. And right now, these things are equivalent. They are equal to each other, and I set up my equation right here to say that x plus 12 is equal to 33. But I want to get my x alone because I want to know what that x is. So I'm going to do the same things I did before with the circle and the square. And I'm going to get rid of the thing that's in the way of my x, which is that plus 12 right here. So instead of adding 12 to the x, I'm going to take away that whole value of 12. I'm going to subtract 12 here. But once I take away the 12, that makes my scale unbalanced. The only way to get it to balance out again would be to take away the same amount from the other side. So I took away 12 over here, and now I'm going to have to also take away 12 here. So as you see right here, that's what I did. The 12 is gone from this side, and it has been taken away from this side. And that works out for my equation here. I had x plus 12, and I took away 12, equals the amount of 33 minus 12. So all I have to do is subtract 12 from 33, and I would get the answer of x equals 21. So we kept our equation balanced the whole time. We didn't make it lopsided, and then we were able to solve for the answer. Let's try another one. 2x is equal to 132. Okay, but we want to solve for x. So we have to get rid of the other thing that's on the scale with the x. So I'm going to get rid of that 2. Now, how do I get rid of that 2? I have to think about what that 2 means. That means 2 times x. That means 2 times x. So instead of multiplying by 2, I'm going to divide by 2. So when I divide by 2, that gets rid of the 2 on the left, but it makes my scale unbalanced. So I'm going to have to do something to the right side to make this scale balanced. If I divided by 2 on the left, I'm also going to have to divide by 2 on the right. So over here, I divide by 2 on the right. And then my equation, after dividing by 2 over here, dividing by 2 here, I get x equals 66. And that would be my final answer. Okay, now I want you to try the rest of the problems in the Investigation 7. And I'm just going to walk through one of those that you're going to get to at the end. Numbers 15 through 19 are slightly different because there's no actual scales there. I'm going to walk through problem 15 for you. So you can pause the video now, do those questions until you get to number 15, and then come back here if you need some help. So it says x plus 2.5 equals 7. So let's think about our scale. This is like the left of our scale, and this is like the right. And I want to get that x alone. That's my goal. So I have to get rid of everything that's in my way. So I'm going to start off by getting rid of this 2.5 over here. But I can't just stop there. I can't just get rid of this 2.5 and do nothing else, because now it's not equivalent anymore. X doesn't equal 7. X plus 2.5 equals 7. So to keep it equal, I'm going to have to subtract the same thing on this side of my scale. Then I have x equals the amount of 7 minus 2.5, which I know to be 4.5. And that would be my final answer. Thanks for watching.